Hi, this is Mike Henriksen from Strata San Jose. I'm here with Dinesh from IBM. Dinesh, how you doing?
I'm doing great, wonderful.
So you gave a keynote this morning, and I thought it was very nice. You talked about operationalizing machine learning. Can you unpack that a little bit for us?
Sure. So as part of the keynote, I also talked about the three pillars or the three aspects of machine learning. So there's the data piece, where how do you bring in the data, you cleanse the data, understand the data, shape the data. And then the second pillar is the development of the models, where once you have the data, what algorithm to use, how do you score, how do you train, right? The last pillar is the deployment, which is operationalizing that model that you have built into your enterprise. And Mike, I think that is the most critical piece, because think about it. If you are an enterprise, right, most enterprises has been around for 40, 50, 60 years. So they already have an infrastructure that's built with applications that's third party that they cannot touch. Software that was written in the 50s and 60s and 70s, that is hard to change. Rules engine that already makes decision for you. How do you infuse ML into it? How do you bring that model that you've written in R or Python into that infrastructure? That is the struggle, that is the challenge that enterprises face today. So that's what I meant by operationalizing your models that you have written in a notebook will stay in your notebook unless you can bring that into that infrastructure.
So is that, in a way, operationalizing, making it repeatable?
Right, operationalizing in the sense that deploying it, and let me expand on it. So when I say operationalizing it, let me give you three aspects or three examples to it. So let's say you deployed the model. What if the model becomes stale, right? Which will happen as the data changes, the scoring will go low. So then you need to look at it and say, okay, how do I retrain that model without taking it offline? Can you add a feedback loop whereby which the model is getting real-time trained using real-time data? Or let's take another example where how do you make sure the model management is in place? So who deployed the model, right? Where was it deployed? Was it in QA? Was it in development? When was it changed? Who changed it? All those, the whole life cycle of the model management is so critical. And the third piece, like I said, a lot of customers have legacy applications like COBOL, for example, that is sitting there. Now you have a Python model that you have written, or an R or a Scala. How do you marry those two, right? Those are the challenges. Now you want a fast scoring engine that can take these two together and have an API call to it. Those are the real challenges our customers are facing. The middle piece of development of a model is getting more and more commoditized, right? I mean, you look at open source TensorFlow, you look at MXNet. I mean, there's the framework itself is going to get more and more commoditized. But how do you get to that last pillar? That is going to be the real challenge.
Well, and also you mentioned real, which is a really important word.
Right.
Because it seems like a lot of data science is showing things in a competitive competition style. Like, is it real?
Right.
Is it making customers have better success? Is it giving them better value? Is it giving them the results they want to see? So how do you get from the competition mentality to real?
So, good question. So if you look at a data science competition, not a lot of times, majority of the times, the data is given to you and it's cleansed. So you already have clean data, right? Then the second piece is that the problem is defined. What is that you're competing for, right? The scope is limited, meaning you are told that here's the problem. And the third piece is that, you're competing for a log loss of 0.0001, which is very, from a decimal perspective. But how often, Mike, in real world, your problem is defined? I mean, you have to figure out, when the data comes in, is it clean? 90% of the time, the data is not going to be clean. You have to figure out, are values missing? So I'll give you another example. So if we are working with an insurance company where the data comes in, a lot of times, the gender field is missing. How do you figure out if this patient is a male or a female? You have to see if this patient has made a visit to the doctor for a prostate exam, he's a male. If it's a gynecological exam, it's a female. So there is a lot of intuition work goes into just to clean the data. So that's why I say competition is competition. It's good. It's really good for the industry. It's really good. But the real world problems is totally different.
So how does a large enterprise get going with putting this into practice in a real way that is meaningful to their organization? How do they work with you guys to actually make that happen?
Right. So we have a lot of customers, enterprise customers, dozens of enterprise customers who are working with us. And the challenge is that, look, today they have, like I said, the infrastructure existing. Now we need to figure out where do we infuse ML, right? How is machine learning going to augment what they're doing today? It's not about replacement, it's about augmenting the technology they have. So can we make it more predictive? And once you make a prediction, can you optimize that prediction? And once you make that optimized prediction, can you make a decision on it, right? So when people talk about machine learning, it's about prediction. That's what it comes down to. But there is a whole segment right after prediction. How do you optimize that prediction, right? So let's say you are a trucking company. You have predicted that this is the best route, but is there an optimized route? And can you make a decision based on that prediction that you have made? So there is a lot of different paths, segments you can take, and we as IBM can come in, and because we know your enterprise space better than anyone else, and that I can vouch to it, right? Now we can come in and say, okay, here is your architecture, here's how things work. How do we infuse ML into it? And it's not a competition, it's a journey.
Yeah.
So you need to make sure that you have somebody who is with you from step one to step N, and that's not a 1 day or 2 day.
Well, I totally hear the journey. And so in that journey, what are some of the common challenges that have a customer kind of stub their toe a little bit as they get going? What are some of the challenges you see for large enterprises to actually get business value out of using machine learning?
Right. So the first challenge is that there is a craze or a rage about the whole machine learning, deep learning space right now. Mm-hmm. Everybody wants to, say that they have machine learning or deep learning. Now, what as a customer you need to look at is first is a use case. Where does that machine learning fit, right? How can I optimize or make more inroads in what I am doing today? And how do I make sure I improve my business by doing machine learning? So the first step is picking the use case. And there are certain use cases where you could probably use I don't want to say simple, but a logistic regression, for example, or a linear regression. You don't have to go all the way to the neural nets and all those things, right? The benefit of going that path is that, one, it's faster to train, mm-hmm. easier to tune, like if you have hypertunes.
Right. Yeah.
And then there's a third piece, Mike, that's rarely talked about is explanation of that model. And I'll give you an example of that. So let's say you're a bank. You have a loan processing model that you've built. You have declined that loan to me as a consumer. I'm going to come to you and say, why did you decline my loan? You should be able to explain to me the reason behind that.
Boom, boom.
Right.
In fairness.
Right. So the more complicated the model gets, the layers of neural nets you have, the harder or maybe impossible for you to explain it. Or if a regulator comes to you and say, what happened? You should be able to say, was it transparent? Was it fair? Was there discriminatory practices there? Was there bias there? All those things you should be able to explain. Another example that we're working with the insurance companies that they're taking the patient's vital signs and then making it prediction on when to bring in the doctor. One, you better not get that model wrong.
That's a thorny one.
Right.
Yeah.
And two, if you get it wrong, you better be able to explain it, right? So when you say the challenges, we have to come with the customer, and that's why I use the word journey, right? It's a hand in hand because they have the domain expertise, right. We have the technical expertise. How do you combine those two? Infuse ML into the infrastructure that they have. So it's not an easy task, and IBM, given the fact that we have such an in-depth expertise in the enterprise side of things, we can come in, work with customers, bring the deep data science experience and work with them.
So humans and domain expertise are always going to be in that loop and helping to guide the machine learning.
Definitely,
Yeah.
because the humans has to be there, and we always say machine learning, cognitive AI, that will augment the prediction, the decision making, and the optimization of businesses. We don't think it's going to replace it,
Right.
because if you take some of the cases where something happens, you need a human being to be able to intercept that and make the right decision at that point.
Excellent. So Dinesh, if you and I were to sit down 12 months from now,
Sure.
here at the same place,
Sure.
and have a discussion, what would you like to say you guys at IBM have done in that 12 months to improve machine learning for all of your partners and all of your ecosystem?
Right.
What would you like to see happen?
So what I would like to see happen is, like I said, there's three aspects to machine learning. We're investing in all three, right? So if you look at the data piece, we give you tools to clean the data, we give you tools to transform the data, ETL the data. So that piece is very well taken care of. The middle frame, there's Watson with deep learning APIs available where you can do sentiment analysis, you can do speech recognition, voice recognition, all those things. But there's also other technologies that's there. So we are also investing in the middle piece. The third piece is where we really need to bring it together to home to make sure that our customers will adopt it to the existing infrastructure. So if you ask me 12 months, what I would like to see is that I would like to see, one, our investment starting to pay off, especially if we are delivering data science experience, which will encompass that all three pillars, and then seeing our customers more and more adopting, replacing the rules engine or the rules with more and more machine learning, which I really think as a customer will get better service for us, and it will also make us get better support from our customers or the businesses on the other side.
And you learn as they learn, and
Right.
it keeps improving.
Oh yeah,
Yeah.
because I'll give you an example. So let's say you're an airline customer. You want your airline to learn about you as the customer, to understand your preferences, understand your likes and dislikes, so they can serve you better. And that's exactly what machine learning will do. It will learn about you, Mike, as a customer, to understand what do you like when you get into that airport. What are the things, what are the preferences, what are the likes that Mike has, so we can serve him better. And I think so that's a great next 12 months, 24 months we are looking at, where they are not only learning about us as customers, but about serving us better.
Excellent. Dinesh, we look forward to that journey with you.
Well, thank you so much.